Hi, welcome back. In this video, we're going to take a look at a new theorem called the mean value theorem. So the mean value theorem is very, very similar to Rolle's theorem. Remember, Rolle's theorem had three hypotheses. We had a function. It was continuous on a closed interval from A to B, differentiable on the open interval from A to B, and f of A and f of B were the same. So the numbers A and B had the same y-coordinates. And then the conclusion was that somewhere in between A and B, we had a turning around point, and since f was differentiable there, well, we could conclude that the derivative was 0 at the turning around point. So there was a horizontal tangent line in between A and B. So the mean value theorem is very similar, but it only has two hypotheses, the first two hypotheses of Rolle's theorem, and a slightly different conclusion. So the mean value theorem, we suppose that f is continuous on the closed interval from A to B. So that just means it's defined at all those numbers. There's no holes, no jumps, no asymptotes. And it's differentiable on the open interval from A to B. So that just means the derivative exists everywhere in between the numbers A and B. And we can conclude that there's some number C in between A and B where the derivative f prime of C is equal to f of B minus f of A over B minus A. And you should recognize what that quotient is, f of B minus f of A over B minus A. That's just the slope of the secant line joining 2 points on the curve. Let's look at the picture. So here are the two numbers, A and B. And so the function f, the graph of f looks something like that. It's defined at all the numbers between A and B, and it's defined at A and at B. And it's differentiable everywhere in between, so there's no sharp corners, right? So the derivative exists in between A and B. Well, the secant line, joining the points A, f of A, and B, f of B, looks like this, and it has slope, f of B minus f of A over B minus A. So the mean value theorem says that there's some number C in between A and B where the slope of the tangent line is parallel, or the slope of the tangent line is equal to the slope of the secant line. So that means that the tangent line is parallel to the secant line. All right, so that's all the mean value theorem says. And then another way to write that equation in the conclusion of the mean value theorem, if we multiply both sides of the equation by B minus A, we get f prime of C times B minus A is equal to f of B minus f of A. Sometimes this equation is the one we want to use in certain problems. All right, let's look at a quick example. Let's look at f of x equals the natural log of x minus 1. So first, we're going to verify that this function f satisfies both hypotheses of the mean value theorem. And on the closed interval from 2 to 5, and then we're also going to find all the numbers C that satisfy the conclusion. So the hypotheses, we have to check that f is continuous on the closed interval from 2 to 5, and we have to check that f is differentiable on the open interval from 2 to 5. So why is it continuous? Well, it's continuous on that closed interval because the natural log is continuous. The natural log of x minus 1 is continuous on the interval from 1 to positive infinity. So as long as x is greater than 1, that thing is defined. And it's differentiable on the same interval. So it's differentiable on the interval from 1 to positive infinity. So of course, it's differentiable on the interval from 2 to 5. All right, so now we're going to find the numbers c that satisfy the conclusion. So let's differentiate the function. So the derivative of the natural log of x minus 1 is just 1 over x minus 1 times the derivative of x minus 1, which is 1. So f prime of c is just 1 over c minus 1. All right, so what's the slope of the secant line on that interval from 2 to 5? So f of 5 minus f of 2 over 5 minus 2 is the slope of the secant line. So f of 5 is natural log of 5 minus 1, so natural log of 4. And f of 2 is natural log of 1, so natural log of 4 minus natural log of 1 over 5 minus 2. And so that's just natural log of 4 over 3. All right, so we're going to set the derivative f prime of c equal to that slope of that secant line and solve for c. So 1 over c minus 1 is equal to natural log of 4 over 3. We want to solve for c, so we want to get c minus 1 out of that denominator, so we can just flip over both sides. So c minus 1 has to be equal to 3 over natural log of 4. And so if I add 1 to both sides, I get c is just 3 over natural log of 4 plus 1. And we have to verify that that number is in between 2 and 5. And how do we do that? Well, 3 divided by natural log of 4, so as long as the natural log of 4 is less than 3, this number is greater than 2. So we could put it in our calculator and just verify that this is between 2 and 5. All right, so that's the mean value theorem. It's very similar to Rolle's theorem, and you'll get a little practice using it. And I'll see you in some other video.